weeks, what have we been talking about all this time?
About circuits.
We've been talking about circuits. What have we been learning about circuits? We learned about voltage. What else did we learn about?
Resistance.
Resistance, very good. What else did we learn about?
And the other thing, oh my god.
Current, very good.
Current,
See, we
good.
found it. So we learned about voltage, resistance, and current. Voltage, resistance, current are all ways that we explain electricity or how electricity works. Well, what do those words by themselves mean? We're on the right track. Hold on to that for me. So when we talk about voltage, current, and resistance, we need to think about what those words mean. What you got? So they are going to increase, absolutely. What is current? Is current that push forward, or is it the push against?
Well,
Which way does current move? Is it the forward or is it the against?
forward.
That is that forward push. Now, if we want to be a little more formal, a little more proper, we might define current as the flow or the movement, don't mind my writing, the flow of electrons. So remember electrons, those little tiny particles, those negative charges moving in the wires. And we are looking at it at one point, at a single dot in the circuit. The flow of electrons at one point in our circuit. Now we're looking at the flow of electrons and current. What are we looking at for resistance? Are we moving for the electrons or against them?
Against.
We're now moving against, because something is resisting. Fenton, can I borrow you for a second? Aquí. Sí, aquí.
Que vea dónde. Párate.
So if I was an electron, I want to move in this direction. This is current.
Yes.
But now if I want to go back in this direction, Fenton, hold your arm out for me. Just hold your arm out.
Saca tu brazo.
If he has his arm here, can I move as quickly?
No.
Can I move as easily?
No.
I have to use extra energy to move past this point.
Mm-hmm.
That is your resistance. So when we look at current, we're looking at the flow of electrons in this one point, but our resistance is opposition. We're going against flow. Very good. So now we know what current means. We know what resistance means. What do voltage mean? So we have some energy moving forward. We have some energy moving backwards. What is voltage?
The energy.
It's the energy. Is it all of it together, or is it like the difference? What do you guys think? What do you remember?
Or the energy.
Let's think about it this way. How do I find voltage? How do I find V in a math problem?
B.
I.
I. So I. What do we do with I?
Time.
Times. Multiply.
C. S.
You guys are on the right track. Wrong letter. What's the letter for resistance?
Oh, A. No.
R.
Oh.
So A. We do use A for current. Our current is measured in amps, or A. But our resistance is R. So voltage is I times R.
¿Para encontrar qué?
Now, Fenton was mentioning earlier, they might increase, like when current goes up. What happens to resistance when current goes up?
Down.
Resistance should be going down, should be decreasing, because current and resistance are not friends. They don't like each other. So when one goes up, the other goes down. Because they're moving in different directions, we define voltage as the potential difference. We don't actually have that energy quite yet, but we will. So our voltage is potential difference between current and resistance. Potential is a hard word to spell. See, English is Mr. G's first language, but not his best language. That is why we don't know spelling. We know when V goes up, or excuse me, when I goes up, R goes down. What would happen if, for example, V goes up, but I want R to stay the same. I want to stay constant or equal. What's going to happen to I?
Go up.
Go down.
That should also go up. Very good. Because V and I are friends. If one goes up, the other must go up, assuming R does not change. Now, what if we have our V, our friend I, and our friend R, but the I is equal? If V goes down, what happens to R?
Go up.
Go up. No, good.
Some of you say up, some of you say down. Why do you say up?
Because the A
Their
is
friend?
the same.
No, they.
So we know, yes, I is saying the same, and V and R are friends. So why did they go down? Right? They're gonna go down. Let's think about why. Let's do a math problem. Very quick, very easy. We're gonna say that V starts at 20. We're gonna say this is 20 volts. Is equal to, what two numbers can I multiply to get 20?
5.
10.
5. 5 times what? 4. So we'll start our problem with 5 amps, that's where you get our A from, in current, times 4 ohms of resistance. It's that weird little Greek letter. 5 times 4 equals 20. We agree with this, right? But we said V went down. V is less. Now my V, instead of being 20, is 10. My number went down, yes?
Yeah.
We said I, stayed constant. It did not change. What's going to happen to this 4 to make this true? Does 4 go up or does 4 go down? It's going to go down. What is 4 going to become?
2.
It's going to become 2. Very good. So when we are looking at just these letters, V, I, and R, you can plug in random numbers to help remind you. V and R want to move in the same direction. V and I want to move in the same direction. But I and R hate each other. They will always move inverse or opposite of each other. Proud of you guys. Now there's one more thing we learned about. We said we were learning about circuits. What else did we do? We took apart some power strips. If that feels familiar. What did we do when we did that? What did we talk about? Did we talk about different kinds of circuits?
Yes.
What were those kinds of circuits?
Ground.
There are ground wires that helps break up excess electricity. 2 words I'm looking for. One starts with an S, one starts with a P. Yes, say it. One more time, you had it. Yeah, I'll give y'all another hint. Feel familiar?
Parallel.
Yes, series. There we go.
Parallel.
Oh, parallel. Yeah,
Series
yeah,
and
yeah.
parallel.
Yeah,
There we
I
go.
remember now.
What is a series circuit? What does that mean?
A series of
It's
circuits
Circuit connected
together.
the order.
same path.
It's a simple one.
This
I
is
think
circuit connected with the other.
It's connected to other things and it has how many paths?
It has
One.
path.
Very good. A series circuit has one path for electricity. That is the key to a series circuit. No matter how many lights we have connected, there is only one path of electricity. The lights in this classroom, are they series or are they parallel?
Series.
Why are they series? If I
Because
turn one light off, do they all go off?
yes.
Because they are in series. If you break the circuit or if you turn one light off, they all turn off. Is the light outside still on?
No.
Let's check. Is our lights outside this classroom still on?
Yes.
Yes, it is. So is that a series or is that a parallel circuit?
Parallel circuit.
That must be parallel. If series is only